All right, we are looking at lesson 86 and continuing our discussion in Saxon 54 math. We are looking today at multiplying round numbers mentally. You'll notice that there's a lot of emphasis on doing math mentally. It's just good practice for you to be able to exercise your brain and see the patterns and do the computations in your head. But sometimes there also is no substitution for writing things down, going step by step, showing your work so that you don't make any mistakes. But one way that you can do a lot of math in your head is to round numbers and to estimate. It's a very powerful skill that you can use in order to get a quick calculation that will serve its purpose, okay? So, if you haven't already, do your warm-up, and don't forget to go back and look at your multiplication facts here from test G. And here you're again using the patterns of counting by fives in order to do some easier computations with subtraction, addition, and down here, multiplication, some more addition, and subtraction. So make sure you work through those. In this problem-solving exercise, it says how long is segment AB. So let's first of all, let's just stop right there and identify AB. AB is going from point A to point B, obviously. And that distance, if you notice, this mark is 1 inch, and an inch is divided into 4 other segments. So those are going to be quarters. So if you go 1 inch and then another mark there, another segment, that's going to be 1¼ inches. And you can write it like this, a mixed number, 1¼ 1.25, so 1¼ inches. How long is segment BC? So BC is going from point B to point C. This time you're starting not at 0, you're starting somewhere else. So you have a choice here. You can count the number of segments, knowing that each segment is 1/4 inch, or you can find AC and subtract AB. I'm going to approach it in just thinking of this kind of like 0. B is starting at 0, and each of these segments is 1/4. So that's 1, 2, 3, 4. 4 quarters is the same as 1 inch. And then 1, 2 more. So I've got 2 more quarters, 2/4, which is the same as a half. So this is going to be 1½ inches. 1½ for the distance from B to C. Okay? So then it says, how much longer is BC than AB? Well, you're comparing 1¼ to 1½. So 1½ is a little bit longer than 1¼ and it is actually 1 segment longer. So this has 1, 2, 3, 4, 5 segments. 1, 2, 3, 4, 5, 6. And remember, each segment here is 1/4 inch. So BC is 1/4 inch longer than AB. All right. Today's new concept, we are looking at doing some mental math, rounding numbers. So it says here, at one point you memorize multiplication facts. Okay? And once you have done that, you can multiply round numbers in your head. So to do this, we multiply the first digit of the factors and count zeros. So for example, if you take 40 times 30, you know that this is a 0 there is a placeholder. So 40 is not just a 4, but it's a 4 followed by the ones place. And if it's just a 0, that's kind of a placeholder, so that's 40. So if you just take 4 times 3, 4 times 3 you know is 12, and since both of them are tens, 4 tens and 3 tens, you're going to follow that with 2 zeros there at the end. Each of these numbers have a 0 at the end, so you're going to have 2 zeros in your answer, and that's one quick way in order to do a multiplication in your head. So right here, if you take 60 times 80, all you're going to do is take 6 times 8. You know that that's 48, and since there's a 0 in each of those numbers, you're going to add 2 zeros at the end of your product, your answer. Let's look here. 30 times $7. Well, these zeros here are after the decimal point, so really it's 30 times 7 is what you're doing, okay? And those zeros there are just showing that you're talking about currency, so it's $7 exactly, $7 even, and no change or no cents, okay? But if we want to do 30 times 7, you can just take 3 times 7. 3 times 7 is 21, and then you've got a 0 there at the end of the 30, so that's where that 0 comes from. 21 and then a 0. These zeros here are because they want to show that you're talking about value of the money. So you're going to have these 2 zeros dropped in as well to show that we're talking about dollars and cents. So you can do that as well. So there's the 0 there, and then these 2 zeros after the decimal point, you can include those so that you know you're talking about dollars and cents. Here you've got 400 times 700. So you've got 2 zeros at the end, 2 zeros at the end. That's why we're going to have 4 zeros at the end of our answer, and 4 times 7 is 28. 28 followed by 4 zeros is 280,000. So if we were to do these really quickly, you could pause this video right now. This would be a great idea. This is where you could pause it. You try these 4 practice problems on your own, and then come back and check with the video, and let's see if we did them correctly. 7 and 8 is 56. 7 times 8 is 56. Each of these numbers are followed by a 0, so I'm going to add 2 zeros at the end of my product, my answer. 4 times 6 is 24. This 0, I'm going to place at the end of the number, and then point and place those 2 zeros after the decimal point. 4 times 5 is 20, and then I follow it with 2 zeros, so 2,000. 3 times 8 is 24, and I'm going to follow it with 1, 2, 3. 3 zeros total, 24,000. Okay, let's look at the problem set today. Again, pause the video and work through these. Struggle with them, fight with them, wrestle with them, and make sure you get them as correct as possible. Check the answers, and then come back and we'll talk about them here in this video. Number 1, it takes Jennifer 20 minutes to walk to school. So she's going to walk from home to school, and that takes 20 minutes. Notice I sometimes like to draw a diagram. It's a nice way just to organize your thoughts, visualize the problem. At what time should she start for school if she wants to arrive at 8:10? So she wants to arrive at 8:10 a.m., and it takes her 20 minutes. So imagine if you walked backwards, you want to go backwards in time 20 minutes, basically. So if you think of maybe you want to think of a clock, actually, I don't know. So if you've got a clock here, so 8:10 is looking something like this. That would be 6 down here. Okay, so that's 8:10. If you back up 20 minutes, you're going to go counterclockwise. That's 10 minutes. Another 10 minutes would put me right here. So what time is that? Well, this hand's going to move a little bit more towards the 7. So we back up 20 minutes here. Now it's before 8 o'clock. Notice those 10 minutes right there are after 8 o'clock. And then you're going to back up those 10 minutes and then another 10 minutes. So you're going to be at 7:50 or 10 to 8, however you want to say it. Okay? Before her haircut, Rapunzel weighed 125 pounds. After her haircut, she weighed 118. What was the weight of the hair? So you're going to subtract these two numbers, before and after, in order to get the weight of the hair. By the way, you will always see a lot of difference problems, subtraction problems, when they want to find out, the final minus the initial. So this is her final weight, here's her initial weight, here's her after, before, so it's always final minus initial is a very common way to find the difference of something, the change in something. Okay, so often you'll see change written as final minus initial. Lucy bought a hamburger for $2.89, fries for 89 cents, and a drink for 79 cents. The tax was 28. She paid with a $5 bill. How much money should she get back? So look at all these things she has to pay. 289, 89, 79, and 28. So you're going to add all of those up. Find your total cost, okay? That's going to be this value here. And then she paid with a $5 bill. So then you've got to take 5 minus whatever this number is. Okay? So 5 minus the total cost is going to find out what the change is, how much money she should get back. All right, according to this calendar, October 30, 1904, was what day of the week? So we are in 1904. That was a little while ago. October 30, we're in the month of October, and the 30th day is right here. Looks like that is the first day of the week, often called the first day of the week. Okay, Sunday. Here we have marking tallies. We're showing how to tally something using marks. So each of these are 5, that's another 5, that's another 5, and this would be a 1. Or 5, 10, 15, and one more, so that's 16, right? So for 17, you would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That would be the tally method system for the number 17. Round 3,782 to the nearest thousand. So let's write out that number. 3,782, and we're going to round that to the nearest thousand. So here is your number that's in the thousands place. We look at the number right behind it is 5 or bigger, it's 7, okay? And so you're going to round this 7, kicks that 3 up to the next thousand. In other words, 3,782 is closer to 4,000 than it is to 3,000. So this is closer. So we're going to go up to the next thousand, the closest thousand, which would be 4,000. The limousine weighed 2 tons. How many pounds is 2 tons? So there are 2,000 pounds in each ton. So if you take 2,000 times 2, you're going to end up getting 4,000 pounds. I'm also going to set this up just so you can see it using a unit multiplier. So if you've got 2 tons, let's start with 2 tons, and a unit multiplier basically is a way to multiply with a value, a fraction that is just equal to 1 unit, because the two values are really the same, just different units. So we want to go from tons, so I'm going to put tons down here, and I want to go to pounds. I'm going to put pounds up there. Well, there are 2,000 pounds in 1 ton. 1 ton. So this tells me, what do? I take 2 tons times 2,000, and you can put a 1 down there, and 1 times 1. These units of tons are going to cancel. Numerator and denominator, they cancel each other. So that tells me I take 2 times 2,000 in order to get my answer of 4,000. 1/5 of the 45 horses were pintos. How many of the horses were pintos? So 1/5 of 45. Of often means multiplication. So 1/5 times 45. So you can think of that several ways. A fifth means that you're basically dividing by 5. So 45 divided by 5, however you want to think of it. 1/5 is also 20%, 0.20. So you might want to get used to seeing those fractions in and knowing what decimals they're equal to. So you could think of it this way as well. So 45 divided by 5 is going to give you your answer here of 9. Okay? If you want to draw a picture, you could easily draw this, and this is representing all 45, 100%. This is 100%, okay? And then you're going to divide it into fifths. 1, 2, 3, 4, 5. Try to get them as equal as possible. So basically, you're trying to figure out what number added to itself 5 times is going to give me 45. All right? What percent of the horses in problem 8, up here, we just did it, were pintos? So, actually, I already told you that, okay? So, what number added to itself 5 times? Because it's 1/5. 1/5. You divide it into fives here, okay? And up here, there were actual numbers. Okay, 9 plus 9 plus 9 plus 9 plus 9 gives you the number of pintos. Here we're talking about percent. 100%, again, divided into 5 equal parts, you would get 20. 20 plus 20 plus 20 plus 20 plus 20 is equal to 100%. So 1/5 is the same as 20%. Okay? Number 10, which point on the number line below could represent 23,650? So we want to be bigger than 20,000, smaller than 30,000, and 23,000 is less than halfway between 20 and 30,000. So it's got to be less than the halfway point. So here's 20,000, here's 30,000. That's about halfway. That should be 25,000. So it looks like B probably is your best answer. 11, write each decimal number as a fraction. So all you have to do is look and see what is the decimal place. Where is the number in the values there for the decimal places? So 0.1, this is tenths, or it means how many tenths, how many per 10. If it's in that decimal place, that means how many per 100. And if it's in this one, how many per 1,000. So this is, since it's just a 1, 1/10, 1/100th, and 1,000th. If it was some other number besides 1, then you would just put that over the power of 10, whether 10, 100, or 1,000. So 0.21, you look at the last number here, it is in the hundredths place, so this is 21 hundredths. All right, you can work through all of these problems. Keep working on all of these wonderful math skills and different operations that you need to work through. Make sure that you're doing those, checking them, and asking for help if you need them, okay? 19, write each of these numbers with words. So this is 2 and 1/10. This is 2, I don't know, if they say, I read this as 2.1, but it also is 2 and 1/10. Okay? I could write that as a word there, sorry. So these two here are exactly the same value. This one is written as a mixed number, this one is written as a decimal. Here, 100 times 23 cents, so 0.23 is 23 cents. Anytime you multiply by 100, you're going to move the decimal point over to the right 2 places, so that would be 23. And I'll let you continue with these problems, working on all of those operational skills, as well as down here, 26, 27, 28. And I'll wrap it up with you, number 29 and 30, okay? Find the perimeter and area of the square. Now it's a square, 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 square. Make sure you note that. Read carefully. Read carefully. So that means each side here is 10. So the perimeter, you find the distance around. How far would you walk if you walked around this square? 10, another 10, another 10, another 10. So you can do 10 plus 10 plus 10 plus 10, or you can do 4 times 10, which is 40. Don't forget the units. 40 meters would be the distance you walk. Area, you're trying to find out how many squares. How many squares are going to fit this? And each square, if you look at the unit here as meters, each square is going to be 1 meter by 1 meter. Every little square in this big box is a meter by a meter. So how many are going to fit in? Well, you'll have 10 columns across and 10 rows down for a total of 10 times 10 is 100 squares, or 100 square meters. Okay, last problem here. Some combinations of shapes will fit together to cover a flat surface. What two types of polygons are used in the pattern below? So notice this is using two different polygons, and sometimes you can use multiple shapes in order to make a tessellation as long as it's a repeating pattern. So here we've got a square, it looks like. And you've got another polygon here that has 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, so that would be your octagon. Okay? Square and octagon are making that tessellation. All right. Don't hesitate to let me know if you have questions, and keep up the good work.